Hello, dear GMAT 41's channel members, subscribers, and viewers. You are welcome to the GMAT 41's tutorial class on ordinary differential equation. In this video, I'll be teaching you how to obtain the differential equation that has a given primitive. Of course, you would recall that when we talk about primitive, we are referring to the general solution of that differential equation. And of course, you also remember that when you're given a differential equation, you're expected to solve it to get an answer. Alright? That answer is a primitive, is a general solution. Depending on whatever you do with this general solution, you could get its particular solution. Now, when you are given the primitive, that is the solution, how can you determine the differential equation that has that solution? That is the focus of this tutorial. You would recall in our previous class that I taught you how you can be able to obtain the general solution of second order ordinary differential equation. When we considered homogeneous SOODE, that is homogeneous second order ordinary differential equation, I explained that there are these 5 solutions that a student is expected to know. Now, when any second order differential equation is given to you, homogeneous, alright, you use the concept of quadratic equation either by factorization method, or you can use completing the square method, or you might choose to use the quadratic formula method to obtain the roots of the auxiliary equation of this homogeneous SOODE. And once you obtain the root of this equation, your problem is solved. That was what I stated in that class. Because with the roots of this equation, with the zeros of this equation, of this quadratic equation called auxiliary equation, you can easily determine or write out the primitive, the general solution, the complementary function of this given homogeneous second order ordinary differential equation. Please, dear friends, I would like you to watch the screen once again as the 5 general solutions to a homogeneous second order ordinary differential equation displays once again as a reminder, because we treated this in our previous class already. And below this video lesson, you will see the link that will direct you to the video lesson where I taught the general solutions of second order ordinary differential equation homogeneous. However, please watch the screen as the 5 solution displays. So we have these solutions displayed on the board. I'd like you to take a look at it, okay? Now, like I stated, I'd already treated this in our previous class under homogeneous SOODE, alright? And even in the case of first order ordinary differential equation, we've also learned how we can obtain the general solutions of these guys. Alright, so I want to believe that this shouldn't be much of a problem to you again. You can take the video lessons as a reminder. Now, what I'm interested in this solution for showing it to you is the aspect of the root of the given quadratic equation, that is auxiliary equation, of the differential equation that can produce these solutions. Okay? So this root of the equation, we can actually see it in this solution, and I want to point it out to you. Are you following, right? Now look at solution 1 and 2. The m that you have there, they are the root of the equation. Are you getting me, right? They are the root of the equation. Now solution 3, the alpha you have there and the beta, they form the root of the equation. Are you getting me, right? Solution 4 and 5, the beta that you have there, they form the root of the given equation. The equation I'm talking about here is the auxiliary equation, the quadratic equation, as the case might be, that is obtained from the homogeneous second order ordinary differential equation. Please, my dear friends, do well to take that video lesson. Like I said, below this video lesson, you have the link to that video. And at the end of this video, please watch to the end. You see an end screen. Tap that end screen, it will take you directly to the video lesson that explains this solution. Like I said, I'm interested in the roots of the equation as shown in this solution here, okay? Because the roots are what you need. You know, the root of a given quadratic equation is also called the zeros of that quadratic equation. So the roots of the equation, which I told you already, n, alpha, beta, these are the things we need when dealing with this kind of question. And this is just a way of showing you the fastest route, the fastest path, the shortcut that you can apply to determine the differential equation that has any given what? Primitive. So come along, let us do that and see. The first question, 1a, the primitive is y equal to exponential minus 3x. We are asked to find the differential equation that has this. Are you ready? Are you really ready? Come on, let's do this. If you have any question at the end of watching this video, right, you can always drop your question in the comment box below this video. And don't forget, you can join our full learning classes. Become the GMAT 41's channel member to gain much more benefit. Are you following, right? To follow our classes step by step so that you don't miss out. Alright, 1a. What do we do there to get the differential equation that has this primitive? Now, I'm not interested in any other thing apart from the root of the given solution. That guy that is the root appearing in this solution. Here, I have y equal to exponential minus 3x. Clearly, the root of the equation is the guy multiplying that x there, which is minus 3. Okay, that's the root of the equation. So I'm simply going to write that m is equal to minus 3. And then bring this minus 3 to meet m. Hey, that friend, this is the secret. What I'm trying to do here now is simply that thing we know, we learned in our O level. When I talk about O level, secondary school level, college level, as a matter of fact, I can even tell you that those in primary 5 and 6, yeah, some of them are being exposed into this area as well too sometimes. Am I communicating? Quadratic equation. Do you still remember how to obtain a given quadratic equation from the roots of that equation? That is the secret I'm using here as a shortcut to dealing with this. There are actually two methods you can use to obtain the differential equation that has a given primitive. But the shortest of the cut of the path is what I'm doing here, okay? Using the knowledge of how to get a quadratic equation from a given root. So follow along as I do that. I'm going to move this minus 3 to meet m, and that will give me m plus 3 equal to what? 0. My problem is solved. I have obtained that differential equation that has this solution. Now, all you need to know is recall, note. Let me give it to you as a note. M as used here, if I am translating this thing back into the differential equation that has this primitive, you want to remember that m represents this operator, d dx. In this case, m is raised to power what? 1. M is raised to power 1, which means that d dx will be first order. Will be what? First order. So this is simply going to be, therefore, the dE is place of this m is raised to power 1, meaning that the variable has been differentiated once. And that operator is now going to be dy dx, then plus 3y. When m is raised to power 1, it means that d dx is first derivative of the dependent variable y. Are you getting me right? Suppose m is raised to power 2, as we might see in some cases. We're now going to have d2y d squared x. Please don't worry, you're going to see all of this as we solve this question. Now, why did I introduce y to this 3? Because in this case, if I decide to force m to enter that 3 there, it's going to be 3 times n raised to power 0. Simply 3n to the power of 0. That m will be power what? 0. That 0 simply tells you that the dependent variable there, y, has not been differentiated. Once again, that m raised to power 0 there means that this operator does not exist. Are you following, right? That there is no differentiation done there. That the variable, the dependent variable, which in this case I'm using y, are you following, right, is just on its own there. So this is now going to be 3 times y. And I'm going to equate this to 0. You can still rewrite this as y prime plus 3y equal to 0. You can still rewrite it as d plus 3. This capital D here you're saying means derivative. It is actually power 1 here, so first derivative. Then I'll put y outside there equal to 3, equal to 0 rather. These are various ways that differential equation can be presented. Using the D operator itself, or using the prime notation itself, or using capital D. This is read to mean first derivative of the dependent variable y plus 3y equal to 0. So the dE is any one of these. Are you following, right? It's a very simple concept. Don't worry. I think I have shown you, the trick here. We are now going to be fast in dealing with the rest. Let's move on to the second question. In question 1b, we are expected to obtain the differential equation that has the primitive y equal to cos 4x. Now remember, like I said, you have just one focus here. Can you get the guy that represents the root of the auxiliary equation whose differential equation we are trying to get here? Can we get the root of that guy from the given primitive? Once you're able to obtain the root, your problem is solved. Now let me say this quickly, please. Anytime you have cos or sine in a given primitive, are you following right? You want to always remember that the solution of the auxiliary equation will produce a root that looks like this. M equal to alpha plus minus I beta. The question will now be, is alpha a real number which is not 0, or is alpha equal to 0? Are you following right? Please, I would like you to watch the screen as solution 3 and 4 of the general solution to a homogeneous SOODE still displays, and you will take note of something there. Please watch. Now you see that in solution 3, there is a part that has alpha in it. You see exponential alpha x. Before you don't have that cos beta x and sin beta x stuff. Then you notice in solution 4 that there is nothing like exponential alpha x. Of course, let me give you the secret. The reason is simply because alpha is 0 in that solution 4. So that exponential raised to power 0 times x will give you exponential 0, which is 1. 1 times that bracket will give you that bracket where you have the a cos beta x and plus b sine beta x, okay? So that's just the whole idea. Always remember, anytime you see cos and sine, okay, in a given primitive, it simply tells you that the root of the equation is going to be of this form. Please, dear viewers, you can become the GMAT 41's channel member in order to follow our tutorial classes step by step, so that all these concepts, you will get it even much more clearer. Remember, to become a channel member, it's simple. Just tap below this video lesson, you'll see the join tab. Tap it, alright? You will see our packages displayed. Select any one that is convenient for you. Support GMAT 41 with any one of them that is convenient, with any of the package. Alright? Become a channel member, and I assure you, you will be very grateful that you did. Alright? So you can join us as we coach you step by step in your studies. So come along, let's move on. Now, looking at this is cos 4x. Our beta is 4. Are you following right? There is nothing like exponential something x there. No exponential something times. So this alpha will be equal to 0 in that case. I'm going to write alpha equal to 0 and then beta is equal to 4. Which implies that the root of the equation will take the form, alpha plus minus I beta. Throw away that alpha, which is 0. It doesn't exist. You have plus minus I beta. Our beta is 4, so it's going to be 4i. And so with this, we are now going to split this root of the equation, or the root as seen in this primitive, into 2. Because we have a positive sign and we have a negative sign. This is m equal to 4i. And then, or you have m equal to minus 4i. Move this 4i, and minus 4i to meet m. So this is going to give us m minus 4i in bracket. Then multiply by m plus 4i in bracket equates to what? 0. Alright, you equate this to 0. And then all you need to do is to expand. M times m would give you m squared. M times 4i. Now let's work it together. M times 4i would give you 4in, which will be positive because of this positive sign here, and this is positive. So once again, it's going to be positive 4ni or 4im. Are you following right? Then minus 4i times n would give you minus 4in. So you see you have plus 4im minus 4in. That's going to give you what? 0. So you now be left with minus 4i times plus 4i. I believe we can all expand this, Minus 4i times plus 4i will give us minus, let me open bracket and write 16i squared. 16 what? I squared. Make it equal to 0. And then in the study of complex number in elementary mathematics, I squared is equal to minus 1. Note that I squared is equal to what? Minus 1. Which implies that this is going to be m squared. If this is minus, and this is 16 times minus 1. Are you following? Because this I squared is minus 1, like I said. 16 times minus 1. This is going to give us minus times minus 16, which automatically becomes plus 16 equal to what? 0. Now with this, you can determine or write out the differential equation that has this primitive. Remember, m, like I said, represents that d operator there. Since this is m squared, it means that that d operator is going to be second derivative. Therefore, the differential equation that has that primitive would be m squared is going to be d2y d squared x, then plus 16, this is a constant, no m there, so you're going to multiply that 16 by y equal to 0. So we have, like I said, you can still use the concept of, y prime prime, then you move on, plus 16y equal to 0. You can actually still write the equation like this, and you can still use the capital D notation. The choice is yours. I hope you're learning right. Please, if you do, give a thumbs up to GMaths41. Leave a comment below in the comment section, okay? And of course, to appreciate what you're learning from here. Now let's move on to our question number 2. Here we go. Now we've got this primitive. We have to find the differential equation that has that guy as a solution. Are you following right? So looking at this, we have to extract the numbers representing the roots of the given auxiliary equation whose differential equation we are actually looking for that has this primitive. And looking at this, the root of the auxiliary equation, is going to be this 2 and this minus 5. So I'm going to write m is equal to positive 2 and then n is equal to minus 5. Because moving these numbers to m, you have something like this. And then here you have m plus 5 equal to 0. We're going to expand this. And that's going to be equal to 0. From here, simply, the dE that has this primitive would not be. Know that m squared represents the 2y d squared x plus 3 times m here. This m is raised to power 1. So it represents dy dx. Then minus 10, a constant. You multiply by y and equate towards 0. Let me use this notation. Right, so this is the differential equation that has this solution, that primitive. Alright, let's move on to the next question. Question number 3. And so we'll move on to this business. Question number 3. The primitive is y equal to a sine x plus b cos x. You have no business with the constant of integration there. You have a and b. Your interest is to determine the number that represents the roots, alright, as usual. And of course, we can obtain this from the coefficient of this x here. The coefficient of x here is what? 1. But there's something I told you, I guess, in question number 1b, that once you see sine or cos, you should know the general form in which the root of that equation will take. So recall that n is going to be alpha plus I beta, where in this case, our alpha is going to be 0. Are you following right? Because there is nothing like exponential alpha x in this case. Are you following right? So this thing, based on that solution I showed you earlier, this is actually in line with solution 4. Okay, so alpha is 0, and of course we have our beta to be equal to 1, which means that the root of the equation is going to take the form I beta, alpha is 0 already goes off. This is plus minus, please. Plus minus. So our beta is 1. 1 times I would simply give us what? I. So the root of the equation will now be plus minus I. Plus minus I. Remember, this contains 2 roots in 1. The positive and the what? Negative. So you can actually split and write, m equal to I. You move that I, you get m minus I. Then the second will be m equal to minus I. Again, you move that I, you're going to get m plus I. Equate to 0 and then expand. That's it. Expanding this, m times m would give us m squared, and then I times minus I would give us minus I squared equal to 0. And remember that I squared is minus 1. So if you remove this I squared and fix minus 1, you are going to get m squared minus 1, which automatically becomes plus 1 equal to 0. And what do we have here? Simply replace your m with the differential coefficient term. The differential equation that has this primitive, of course, becomes in this form y prime prime and then plus y equal to 0. If you'd like to use the capital D notation, the choice is yours. It's going to be open bracket capital D plus 1, close your bracket, y equal to 0. This is the differential equation that has this solution. If you are to solve this differential equation, for instance, this is the answer you are going to get. We are moving on. question number 4. This question number 4 is solved exactly as question 2. It's solved exactly as question number what? 2. The only difference is this. Whenever you see this solution, it simply means that the root of the equations are the same. In this case, one of the m is equal to minus 2. The second m is also equal to what? Minus 2. So I'm going to leave that for you to solve. Whatever answer you get, leave the answer in the comment box below this video. I'll be there to check whether you are correct or not. Question 5 and 6 are also the same. They are also the same in the way you handle them. The only difference is that in this case, the exponential term, the coefficient of x there is 0. Watch, let me show you this. It's actually c exponential 0x, which means the root of the equation here is what? M equal to 0. Here, m equal to 1. Here, m equal to what? 2. Are you following, right? So, I think this is what I'm going to do. Alright? Let me solve. Which one will I solve for you, friends? 5 or 6? Tell me, let me know. Which one will I solve? Okay, somehow, some way you prefer I solve 5, right? Prefer I solve 5. Or should I go for 6? Alright, so you want me to handle question number 5, right? I'm going to solve question 5, then you solve question what? 6. It's still the same procedure, okay? So let us see question number 5, how we attack that problem. Because from what I'm saying, it's going to give us an order 3 differential equation, where y is differentiated 3 times. So let's look at it. This is quite interesting, right? Let's look at this. This is the primitive given, and we are asked to find the differential equation that has that guy as solution. So simply move on and extract the numbers that represent the roots here. So we're going to get here, the root is 2. So m is equal to 2. And then we move on to this. We have m equal to 1. The coefficient of x here is 1. And then finally we have m equal to, we want to use m1, m2, m3. The choice is yours. Remember that I told you here that constant c there is actually multiplied by an exponential term. But the root of that auxiliary equation, in that case, one of the solutions will be m equal to 0. So that exponential 0x is going to give you 1. 1 times that c will give you c. Look at that here. Are you following, right? So m in the third part here is going to be 0. Of course, all you have to do is move the numbers to meet m, enclose in bracket, and then expand. And I just did, if 0 crosses, you have m minus 0. M minus 0 is still the same as m plus 0. Are you getting me, right? Anyway, let me just fix minus 0 if you want. Okay, but remember 0 is an integer, belongs to positive and what? Negative. At the end, of course, you know that 0 will be kicked off. M minus 0 is simply n. So why even write that m there, that 0 there? Is it necessary? Just for you to see in case you are solving this one. Are you following, right? So in this case, I'm going to remove that 0. If this 0 were to be a number, if it was to be a number which is not 0, it has to be there. Like in this case now, you're going to have m minus 2. In this case, okay? So for now, let me just wipe this. And then I have something like this, equal to 0. Let us not expand. I'm going to expand this guy first. Whatever I get, I will use this m to multiply it. Is that okay? So we go. This whole term will now be multiplied by this m. And then I'm going to equate it to 0. Now let us use this m to multiply these terms in brackets, and then equal to 0. Because we are done, just copy and paste, the differential equation that has this primitive, because we have obtained it from here. Therefore, the differential equation is going to be, now we have m cubed here, that will represent d 3y d cube x. Are you following? Then you move on, minus 3m squared, which is going to represent 3 times d 2y d squared x. And then plus 2n, which is going to represent 2 times dy dx. There is no pure constant here, no number without n. It means that the y part does not exist in this differential equation. Are you following, right? So once you do that, you equate towards 0. So follow along and you see what I'm talking about. This is, right, so that's the differential equation that has a primitive. Of course, you can still write it in this form, equal to 0. If you still want to use the capital D notation, you can still write it in this format, equal to 0, which reads to mean the third derivative of the dependent variable y minus 3 times the second derivative of the dependent variable y plus 2 times the first derivative of that dependent variable y equal to 0. So that's how you solve this particular problem. And you can see it's actually very easy. Follow the same format I used in question 5. Solve question number 6. please drop your answer in the comment box for review. Let's see how far you understand this solution to question 5. I think it is time for us to look at the last question here, number 7. Are you following? Let's see what we've got. How do we obtain the differential equation that has this primitive? It seems like this wants us to shift this last question to perhaps the next video lesson I'm going to release on ordinary differential equation, right? Because it's not appearing for us to solve. But anyway, don't worry guys. In my next video, we are going to deal with this question. Are you following, right? So make sure you stick around. If you have not subscribed to the GMATS 41's YouTube channel, kindly hit the subscription button. Personalize the subscription by tapping the bell icon and then personalizing it. Are you following, right? Personalize the subscription so that once I upload the video lesson on this, you will be personally notified, all right? But so far, I hope you enjoyed the trick that was used in dealing with this question, how I obtained the differential equation that has this primitive. It's very simple, okay? So there is another general format we use in dealing with this, but don't worry, in subsequent classes, I'm going to put you through that, where you will be expected to differentiate these guys as many times as the number of constants you have in the primitive. Then simplify the equations you're going to get there. Of course, you have something that might lead to simultaneous equation, okay? Like I said, to follow up with what is happening at GMATS 41, what stops you from becoming a channel member? All right? Just click on the join tab below this video lesson, all right? Do so, then select whichever package that is convenient for you, become a channel member, and you get many more benefits exclusively for channel members. Alright guys, make sure you watch this video lesson again and again. Share this video to your friends and to other scholars so that they will benefit from it. Alright? And I hope to meet you in my next video lesson. Don't forget to take your studies seriously.